So here's how our game looks once it's done. We've got a clean interface here with a title on top that says Rock, Paper, Scissors. In the middle, we have a section that shows the current score, both for the player and the computer. And down here, we have three big buttons, Rock, Paper, and Scissors. You click one of these to make your move. Let's try it. I'll click on Rock, and you can see that it shows that I chose Rock, and the computer randomly picked one of the options. Then it instantly tells me whether I won, lost, or it was a draw. The score updates right away, and you can just keep playing as many times as you want. And if you ever want to start fresh, there's a nice red reset button at the bottom that resets both scores and clears the screen. Super clean, super simple, and yet totally built using just Python and Tkinter. No external libraries needed. Hey everyone, today we're going to build a super fun and beginner-friendly Python project, a rock, paper, scissors graphical interface game using Tkinter. This is a perfect project if you've already learned some Python basics and now want to see how everything connects, logic, UI, buttons, scoring, all in one place. We're going to keep it simple but stylish, and by the end of this video, you'll have a complete desktop app that you built from scratch. And just like always, I'll explain everything step by step, so even if you're totally new to the graphical interface in Python or Tkinter, you'll be able to follow along and actually understand what's happening at each line of code. So if you're excited, grab your favorite code editor, open up a blank Python file, and let's build this thing from scratch. Alright, let's start writing our rock, paper, scissors game, and we'll take it step by step. So first, let's import the libraries we need. We're starting with two imports. First is Tkinter, which is Python's built-in library for creating graphical user interface apps, windows, buttons, labels, all that stuff. And we're importing it as TK just to keep things short and clean when we use it later. The second one is random, because we want the computer to be able to randomly choose between rock, paper, and scissors when we play. That's how we simulate the opponent. So imports are done. Now let's build the core of our app using a class. So right here, we're creating a class called RPS Game. This is going to organize our whole game. All the buttons, logic, and screen updates, we'll keep it neatly inside this one class. Inside it, we've got our init method. This is the constructor. It automatically runs when we create an object from this class. And inside it, we pass root. That's going to be our main application window, and we'll create it a bit later at the bottom of the file. Now inside the init method, we start setting up our main application window. So here we write self.root equals root. So what we're doing is taking that root window object, which we'll create at the bottom of our code, and storing it inside the class as self.root. This allows us to use it in other methods inside our class. Basically, we're keeping a reference to the main window so we can modify it anywhere. Now we give our window a title using self.root.title. Whatever you pass here will show up at the top of the app window, like in the title bar. So we write rock, paper, scissors. Now we set the size of the window using geometry. This means we're creating a fixed size window, 600 pixels wide and 500 pixels tall. This gives us enough space to arrange the buttons, score labels, and other elements neatly without making it feel too cluttered. Now we use configure to style the background of the window. We're passing in a hex color code, which gives us a light grayish-blue background. And finally, we call the resizable method and set the value to false, false. This disables the window resizing in both directions, horizontal and vertical. That means users won't be able to drag the edges and mess up the layout. We're basically locking the size in place so that everything stays exactly where we designed it. And if you set the value to true, then users can change the size of the game window. So by this point, our window is ready. It has a title, a fixed size, a background color, and it can't be resized. It's basically our empty canvas, and now we're ready to start placing stuff inside it. Next, we'll define the choices and scores and then start building the actual UI that the player will interact with. Now we're setting up a list called choices, and we're storing it in self.choices. This list holds the three possible moves in our game: rock, paper, and scissors. We're going to use this list later when the computer needs to randomly pick one of these. Like when you click on rock, the computer will choose from this list. And since we're storing it with self, it becomes an instance variable, meaning we can access it in any other method inside the class. Next, we're creating two variables, self.playerscore and self.computerscore, and both are starting at 0. These will keep track of how many rounds the player and the computer have won. Every time someone wins a round, we'll simply increase their score by 1, and we'll update it visually in the app so the player can see how they're doing. And finally, we call self.setupUI, and this is where all the magic of the UI begins. This method is going to build the actual screen, the title, the buttons, the score area, everything the player will see and interact with. We're keeping this part separate in its own method because it keeps our code clean and organized, and it also makes it easier to change the UI later without touching the logic. Alright, we're now creating a method called setupUI. This is where we're going to design the look and feel of our game window. First, we're adding the main title at the top of the window. We're using a label method. We pass in self.root so the label knows it belongs inside the main window. Then we set the text to rock, paper, scissors. That's the title of our game. And then we set the font of our title using the font. Then we set the background color, which matches the window color so it blends in nicely, and we use a dark gray for the text to keep it readable. Finally, we call the pack method and pass pad_y equal to 20. This places the label on the screen and adds vertical padding of 20 pixels to give it some space from the top. Next, we create a frame to hold our score display. So we write self.scoreFrame equal to tk.frame. This is basically a container inside our window, and we'll put our score label inside this box. We set the background of this frame to white, we add a border using BD equal to 2, and give it a nice groove effect for a bit of styling. Then we pack it into the window with some padding so it doesn't sit too close to the title above it. Now, inside that score frame, we add a label called scoreLabel. The text we pass here isn't hard-coded. We call a method named getScoreText, which we'll define soon. That method will return a formatted string showing the current scores. We make the font slightly smaller than the title, and again, we keep the colors clean and readable. We also add padding on the inside using pad_x and pad_y so the score text doesn't feel cramped inside the frame. And just like before, we call the pack method to place the label inside the frame. Alright, now let's create a variable called resultLabel. This is going to be the part of our app that displays the outcome of each round, like whether the player won, lost, or if it was a draw. So we write self.resultLabel equal to tk.label. We're using Tkinter's label here, and since this label belongs in our main window, the first thing we pass is self.root. That tells Tkinter, hey, put this label inside the main window. Then we pass an empty string to text, meaning the label starts off empty. We're not showing any result just yet. We'll update it later dynamically when the player makes a move. Next, we set the font using font. This makes the result text large and bold so it stands out clearly after each round. Then we set the background color and finally set the text color. And right after creating the label, we use the pack method to place it on the screen and set 10 pixels of padding on the top and bottom. Once we start playing the game, we'll update this label in real time to say things like you win or you lose, depending on what happens in the round. Now we're going to create a label that tells us what the player chose during the game. So we write self.playerChoiceLabel equal to tk.label. We're storing this in a variable called playerChoiceLabel, and again, we're using tk.label, which is the basic label widget in Tkinter. Inside the parentheses, the first argument is self.root, which means this label is going to be placed in our main window. Then we set the empty string to text. This means the label starts off blank because we don't know the player's choice yet. Next, we define the font, background color, and text color. Now we use the pack method to actually place this label on the screen. We don't add any padding here since we'll be stacking multiple elements in this section and we want them to be close together for a clean layout. And right below this, we create another label, this time for the computer's choice. So we write self.computerChoiceLabel equal to tk.label. And everything else is pretty much the same as before. It goes in the same window, that's why we pass self.root. It starts with empty text, uses the same font size of 12, has the same background and foreground colors, and is placed just below the player's choice label. And finally, we use the pack method to add this label to the window as well. So now, after every round, we'll update these two labels dynamically. One will say something like, you chose rock, and the other will say, computer chose paper. So by now, we've got the title, the score, the result label, and now the choice indicators. Next up, let's create the buttons for rock, paper, and scissors so the player can actually make a move. First, we create a new frame that will hold all three buttons side by side. So we write self.buttonFrame equal to tk.frame. Again, we're placing it inside the main window by passing self.root. We also set the background to match the rest of the app. This keeps the layout consistent and clean. Now we pack the button frame into the window using the pack method and set the pad Y to 20. This adds some vertical spacing so the buttons don't sit too close to the choice labels above them. Alright, now that we have the frame in place, let's create the actual rock, paper, and scissors buttons. We're calling a helper method called createChoiceButton 3 times, once for each option, rock, paper, and scissors. Each time we pass in 2 things. First, the name of the choice, like rock or paper, and second, the color, to make each button visually distinct. So we set the rock to gray color, paper to light blue, and scissors to orange. Now we define a method called createChoiceButton, and it takes 2 parameters, name and color. This lets us reuse this method for all 3 buttons. We just pass in the text and the color we want, and it builds the button accordingly. Inside this method, we create a variable called btn and set it equal to tk.button. Now inside this method, we first write self.buttonFrame. This will place the button inside the button frame we created earlier, so all buttons line up next to each other. Then we set the text equal to name, which sets the button label like rock or paper. Then we set the font, background color, and text color, and we also set the width to 10, which will give the button a fixed width so all 3 buttons are of the same size. And then we add some vertical padding inside the button using the pad Y. Then we set the active background to dark blue color and the active foreground color to white. Now what this will do is, it will change how the button looks when it's clicked, a dark blue background with white text. And finally, the command part is the most important. This tells the button what to do when it gets clicked. We use a lambda function here so we can pass the correct choice, rock, paper, or scissors in lowercase, and call self.playRound with that value. Now we use the pack method to place the buttons side by side within the frame. Here, we set the side equal to left, which means each button will sit next to the previous one in a row. And pad X equal to 15 gives each button some horizontal spacing so they don't look squished together. So that's how we create all 3 buttons, rock, paper, and scissors, each one styled differently and wired to the game logic. Next, we'll add the final piece of the UI, the reset button, which lets the player restart the game and clear everything. Now we're creating the reset button. This time, we're not storing it in a variable because we're only using it once, right here. So we start with tk.button, and just like the others, we're passing a bunch of properties to customize how it looks and behaves. First, we write self.root, because this button will go directly into the main window, not inside any frame. Then we set the text to the reset string. Then we set the font, background, and the text color, and also we add the internal spacing using the pad X and pad Y just to give the button a nice shape and size. Now again, the most important part is the command equal self.resetGame. What this will do is, when the player clicks this button, it will call a reset game method, and that's where we'll define what should happen when the game resets. And finally, we end it with the pack method, which places the reset button on the screen and adds 15 pixels of vertical space. So now we've completed the full interface. We've got a clean title, score tracking, dynamic labels for results and choices, buttons for player interaction, and a reset button to start fresh whenever needed. Now we're going to build the actual game logic, the part that decides who wins each round, updates scores, and makes everything interactive. So now we're creating a simple method called getScoreText. What this does is it builds a string that shows the current score of both the player and the computer. We return an F string that looks something like this. Now remember, self.playerscore and self.computerscore are variables we initialized at the start of our class. They store the actual numbers of how many rounds each side has won. So every time we call getScoreText, this function returns an up-to-date score in a clean, readable format. That's why we used this method when we first created the score label in the UI and again after every round, so the score label is always accurate. Now we'll create a new method called playRound. This function is triggered every time the player clicks one of the buttons, rock, paper, or scissors. It takes one argument, player choice, which will be a string like rock, paper, or scissors depending on what the player clicked. Remember, we connected this method to the buttons earlier using a lambda function, so this is where that value ends up. First, we need the computer to make its move, so we create a variable called computerChoice and set it equal to random.choice, and inside it, we will pass our choices list that we created earlier. This line picks one item randomly from the list self.choices, which contains rock, paper, and scissors. So every time the player clicks a button, the computer also silently chooses one of the three options. Next, we update those two labels we created earlier to show what each side picked. First, we write self.playerChoiceLabel.config. Now this will update the player's label with their choice. Here, we use the F string to display the text like "you chose rock," and the capitalized part just makes sure the first letter is uppercase for a cleaner look. We do the same thing for the computer's choice with self.computerChoiceLabel.config. Now, we call a method named getWinner, which we'll define separately. We pass both the player's and the computer's choices to it, and it will return a value like player, computer, or draw, depending on who won the round. And we store the result in a variable called winner. Now, based on who won, we update the scores and show the result message on screen using the if-else statement. So, if the winner is player, we increase the self.playerScore by 1, update the result label to say you win, and set the text color to green. And if the computer wins, we do the same for self.computerScore and show you lose and set the text color to red. And if it's a draw, we display it's a draw and set the text color to blue. So every time a round is played, the score and the result area are updated instantly. And finally, we update the main score display. We call self.getScoreText, which returns a nicely formatted string showing both scores, and then we use config to update the label on screen. And that's it. This method takes care of getting the players and computers' choices, deciding who wins, updating the scores, and displaying all the results to the user. Now, we will compare the player's move with the computer's move and decide who wins the round. So here, we're defining a method called getWinner, and it takes in two arguments: player, which is the move the player chose, and computer, which is the move the computer randomly picked. So for example, if the player clicked rock and the computer chose scissors, those values come in here. Now, based on these two values, we'll figure out the result, who wins or whether it's a draw. The very first thing we check is, are both choices the same? If yes, that means it's a draw. No one wins. So we return draw right away, and the function ends here if both choose the same thing. Now, if it's not a draw, we check for all the possible ways the player can win. These are the classic rock, paper, scissors rules. Rock beats scissors, paper beats rock, scissors beats paper. So we're checking all those conditions here using the OR operator. If any of them is true, it means the player has won, and we return player. And finally, if none of the conditions above matched, that means the computer won, so we just return computer here. Simple as that. 3 possible results: player if the player wins, computer if the computer wins, and draw if both pick the same thing. So now, whenever a round is played, this method quietly figures out the outcome and passes it back to the play round method, which updates the UI accordingly. Alright, we've covered the core game logic. Now, the last thing that we need to do is, we need to write the logic for the reset button. So here, we define a new method called resetGame. This method doesn't take any arguments, it just resets everything inside our app to its original state. And we connected this to the reset button earlier using the command =self.resetGame. So when the player clicks that button, this function will run. First thing we do is reset both scores back to 0. So we write self.playerscore = 0 and self.computerscore = 0. This brings both sides back to the starting point. So if you had, say, 3 wins and the computer had 2, this will erase that and take us back to a fresh game. Next, we clear out the result message, the one that says you win or you lose. We do that by calling the config on the result label and sets the empty string to text. This empties it out so there's no leftover message on screen. Then we clear both the player's and the computer's choices, because once we hit the reset button, we don't want the choices to display. Again, we just pass an empty string to text, so those labels are blank. Finally, we update the score label at the top of the window to reflect that both scores are now 0, and we use self.getScoreText to get the updated string. And that's it. When the player hits reset, this function resets the scores, clears the previous round's result, empties the labels for player and computer choices, and updates the score display. So we're back to a clean slate and ready for a new game. Now that we've built the full UI and all the logic methods, there's just one more part. This is the part that actually launches the app and starts the main game window. So first we write if underscore underscore name underscore underscore equal to underscore underscore main underscore underscore. Now this line might look a bit strange if you're new to Python, but it's a very common pattern. I have already made one video on this in which I have explained what it means and what it does in detail, so if you don't know what it does, you can watch that video. So what this line is saying is, only run the following block of code if this file is being run directly, not imported into another file. So if we just open and run this file as a standalone program, the code inside this block will run. But if someone tries to import this code into another script, this part won't run automatically, which is a good safety measure. So inside this block, the very first thing we do is create the main window for our app. We create a variable called root and set it equal to tk.tk. This initializes the main Tkinter window where our entire program will live. Next, we create an instance of our RPS game class, the one we spent the whole video building. We call it app equal to RPS game, and by passing in root, we're saying, hey, build all the widgets and layout inside this main window. This runs the init method of our class and sets up everything we've coded, score tracking, buttons, result messages, and so on. And finally, we call root.mainLoop, and what this does is start the Tkinter event loop. That means the window stays on the screen and it waits for the user to interact, like clicking buttons or closing the app. Without this line, your GUI would just flash open and instantly close, so this is essential to keep the app running and interactive. And that's it. We've now walked through every single line of our rock, paper, scissors GUI game, step by step. But before we end the video, let's actually run the program, click around, and test everything to see it in action.